Very excited to present our work, Pseudo-Labeling for Domain-Agnostic Bangla Automatic Speech Recognition. My co-authors are Mehadi Menon, Tariqul, Muntasir, Sagor, Sarker, Quazi, Sarwar, Muhtaseem, Tariqul from Singapore Private Limited, and Shammur Chowdhury and Firoj from Other Company Research Institute. Firstly, our objective is to work on develop a large level speech dataset for Bengali ASR as Bangla is a low resource language. So, such kind of resources are not available for ASR research and development. So, and then also we train a end-to-end automatic speech recognition model to understand the dataset effectiveness and quality against other available resources. So in our work, we actually propose a pseudo-labeling approaches that directly aligned with our collected data set. And also we develop a 20K hours Bangla transcript speech corpus. So far, this is the largest one. And also to train an end-to-end ASR model. Beside this, we released 2 new test set. One is telephony data and other is diverse domain YouTube data set. And our model also available in this. So the core thing in our work is data collection and labeling. So during the data collection, firstly, we selected some predefined YouTube channel list that actually contains Bengali videos, Bangla videos. And then we downloaded the videos from the channels. And then the audios are extracted in opus format from this video. And finally, the opus files are converted to WAV 16 kilohertz format that is directly used for training and other work. So another core thing in our work, pseudo-labeling algorithm that we used. So 2 main components of the algorithm. One is 2 ASR model, Kaldi-based and conformer CTC model. So conformer CTC is end-to-end ASR model. And we use an alignment function and for longest substring matching. So the algorithm works like for each pair of transcription for a given audio from those 2 models, the alignment algorithm returns the common subsequence of those 2 transcription after filtering the mismatched segments. Then for every segment, the word rate, segment duration, total character, total words are calculated, and also checking with some predefined filtering. And finally, after the filtered segments, other segments are taken as the final transcription. There is an example. So one output for a given audio, one output from Nemo and other output from Kaldi model. And we found that the red colored segments are discarded from the subsequent alignment function, and the common segments are taken for further processing. So then the segments are further filtered with some conditions, and for the filtered segments, which actually we don't consider for transcription, are also filtered from the audio, as the Kaldi ASR provides the time stamp for each word. So we also edit the original audio, and then we take the aligned transcription with audio. Our collected data set so far 20K hours, and from this 20K hours, 18K hours data we are taken for training, and the rest 2K hours data we take for validation and testing. In our testing set, there are 2 kinds of data. One is Megabn speech YouTube test set with 8 hours and other telephony data with 1.9 hours. In the training set, there are basically 4 major category: news, talk show, blog, and crime show. And among 4 category, news category has about 17,064 hours data, and Toxo has 688 hours data. So after collecting and creating the corpus with training a fast conformer model, which is the end-to-end model, and also its implementation available in NVIDIA NeMo library. So use this code base. And for training, we use 16 A400 40 GB RAM GPUs. And we conducted the experiment for 15 epoch. We use RAM W optimizer, and there are about 90K 90K global step. And we use some default configuration that is available in their configuration file. So after the training, uh, we uh, we do some work on data processing, as the training data is fully dependent on the model generated transcription, but the test set is prepared with by human level annotation. So there is a mismatch between the writing style from the model output and from the user. So to minimize the gap from the writing style, we use an global mapping file we manually prepared by analyzing the transcription data. For an example, there is a word Chowdhury. So the pronunciation is same, but the writing style is different. And there is a difference in on character in the word. So and also we use some common way for like number to word conversation and punctuation removal during WR calculation, and NFC normalization are used there on the transcription text set. And at the evaluation time, we use 4 ASR model. One is prepared by ourselves, Mehadi and Space on the collected data, and other 3 from Google ASR, MMS from Facebook, and ODD from Bengali.ai. And 4 data set, two, two are prepared for ourselves, Mehadi and Space YouTube test set and the telephony test set, and other 2 is full words and common voice. Those 2 data set are very popular for evaluating and training ASR model. So in this table, there we found that for our prepared test set, our model is superior than other models. So there is an important intuition that for telephony test set, our model has 40.7 watt error rate, where Google, the second best, has 59 watt error rate. Yes, the data set is fully unbiased from the training set, and the source is very different. But we found that our model is better than other 3 models. So we can say that probably for telephony data, our model is better. So if further we fine tune the baseline model that we prepared for telephony data, maybe the word related will be minimized more again. And also for YouTube test set, our model is better. And for full words and common voice, we found that Google has better than other, as it's were rated minimum among those. But our model is also competitive with MMS model. So the next table is actually categorical distribution on our YouTube test set. As our training data set only has 4 major categories, but during the preparation test set, the collected videos are like very recent videos, and the category also there are more category, like 9 category. So we found that for all category, our model provides less word error rate and character error rate than other models. We can say that, like for some application like subtitle generation for Bangla videos, maybe our model will be better than other models. So there is on discussion topics that the effectiveness of pseudo-labeling over fully supervised. As pseudo-labeling technique needs a lot less effort to labeling the data set. So it maybe takes more less time to training a diverse ASR model that can work on different domain. So generalization capability will be increased for pseudo-labeling ASR based ASR. Yeah, there is one limitation of pseudo-labeling, that it has some errors. So we need to compromise those errors. So from our experiment, we found that we take a sample training set, and further we manually label the training audio, and then we check the error from our pseudo-labeling transcription with human label. We found that about 2 to 2.5% error in our transcription. So there is a in future work, so we can work to enhance the pseudo labeling technique, and we found that and also other thing is that work with more data. As we work there on YouTube data, so we can consider other resources there to prepare a more bigger or larger corpus. And the rest is that similar experiment can be done with other low resource language like Tamil and some African language also. Our source code is available in GitHub also. So thank you everyone.
Thank you.
Yeah, so any question?
Yeah, do you have any question? Anyone? In person or remote?
I have a question. Like in slide number 9, if I see the last samples of the GLM sample, like text rewrite to text. So text, I think text is not found in Bangla dictionary or something like that. So the pronunciation or the pronunciation is different from text to text. So the reason behind changing text to text, can we specify?
Yeah, actually, so actually, yeah, so here actually, yeah, we firstly we consider the common words, very common and available in the Bangla dictionary, but also we then we prioritize on some word that actually like very related. So like as text is a English word, so actually it is English word, but we commonly use in like in our conversation, and so as it is not a pure Bangla word, so we consider it.
Hi, I just want to add over here. So when checking the annotation manually, there were a few spelling mistakes by the annotator or transcriber. So in that case, we added those mistakes in the GLM file. So that's the spelling from the human annotation.
Okay, thank you.
All right. Let's thank the speaker. So we'll move ahead to the next talk. The paper title is Contextual Bangla Neural Stammer, Finding Contextualized Root Word Representations for Bangla Words. It's a paper by Muhammad Fahim, Amin Ahsan Ali, M. Ashraful Amin, and AKM Mahbur Rahman. It's a remote talk.
Can you hear me?
Yes.
Are you able to see my slides?
Yes.
Okay.
Loading. Okay, we can see you and hear you.
Hello everyone, welcome to our
So
presentation.
10 minutes for talk and 2 minutes for QA.
Okay. Hello everyone, welcome to our presentation. Today we are going to present our paper titled Contextualized Bangla Neural Stammer, Finding Contextualized Root Word Representation for Bangla Words.